Okay, this is a long question, and this is my second attempt. Here we go. What's the initial number of atoms of sodium-24? Well, she mixes it here with 2,000 and then only takes 20, so that's 1/100th of the original atoms. She starts with 0.1 nanograms. So I've got 1/100th of 0.1 nanograms. And that's 1 times 10 to the minus 12 atoms. Sorry, 1 times 10 to the minus 12 grams. Now compare that with molar mass, which is 24 grams. That would be 6 times 10 to the 23 atoms. So take 6 times 10 to the 23, divide it by 24, and times it by 1 times 10 to the minus 12. And that gives me 2.5 times 10 to the 10 atoms. So that's 2.5 times 10 to the 10. The activity is going to be lambda n. Remember, lambda we can work out with ln2 divided by the half-life. The half-life is 16 hours, so it's 16 times 3,600. ln2 divided by that, that gives me 1.2. Oh, and then I multiply that by n. So multiply that by 2.5 times 10 to the 10. And that's 3 times 10 to the 5 becquerel. Pretty accurate, it's 3.00. So next up. She extracts 15 centimeters cubed and she measures the activity at 2200. Okay, well, let's start with this. What's the total activity in the flask after 8 hours? It's going to be the original activity, 3 times 10 to the 5. And that's a half of a half-life. So it's a half to the power of a half. It's going to be the new activity. So the new activity is 2.13 times 10 to the 5 becquerel. That's the whole flask. But she extracts 15 centimeters cubed, and that has an activity of 2,200 becquerel. So we can work out the volume of the whole flask by scaling back up again. We do 15 divided by 2,200 times 2.13 times 10 to the 5, and that gives us 1,452 centimeters cubed.